So welcome to this video on 2012 question B1. Alright, we have to draw a given end view. Okay, include the straight line elements of the surface in the cylinder, project the elevation, locate two focal points and find the center of curvature. Right, we'll have a quick look at what the object looks like in 3D. So the building looks like this in 3D. Cylinder intersecting rectangular prism, front face. That's it in 3D. Okay, I'll have to fix that. That line actually doesn't exist. Sorry, never mind there. What is that? Line doesn't exist. End elevation. There. Elevation. End elevation. Plan view. It's a right base cylinder, and it's the base of the cylinder. Okay, it makes an angle of 30 degrees to the horizontal plane, and the axis of the cylinder is at 60 degrees to the horizontal plane. So we'll read out the question, and I sketch the question, okay, out how to do it. So I won't read too much of that. Keyword is right cylinder. So that's a solid whose axis makes a 90 degree angle with its base. So B1 shows the elevation and end view. Okay, right cylinder, its axis is inclined at 60 degrees to the horizontal plane. So the XY in elevation and end elevation represents an edge view of the horizontal plane. So there's the horizontal plane, okay, in 3D. There it is there appearing as the XY line, okay, in elevation and then elevation. Okay, and the cylinder intersects the vertical front face of the building, producing elliptical curves as shown in the elevation. So those curves there, and you can see them there and there. Okay, part A, draw the given end view, include the straight line elements on the surface of the cylinder as shown. Like down there, and this is what that means. That's them in 3D. So we'll sketch out this question. Okay, we'll sketch it out first. So we can draw our XY line. Okay, we're going to draw a line at an angle of 60 degrees for the axis. So a point on the base is up, okay, 3 meters in real life, so 30 millimeters, because the scale is 1 to 100. So 1 meter equals 1,000 millimeters. Okay, divide by 100. Okay, you get what you call it. 1 meter, okay, is equal to 10 millimeters. So 10 meters is equal to 10 millimeters, and 3 meters rather. Okay, 1 meter is equal to 10. I've done that already, so 3 meters is equal to 30 millimeters. Now, so we're going to go up 30 from our XY line across, 30 degree line here. So there's the base of our cylinder. Okay, the extreme generator is parallel to the axis. So where does it stop? Okay, well, if we go straight up from the point on the axis, okay, that's where the top of it is. Then this line is parallel to the base, so it's at 30 degrees. Now, how do we figure out this rectangular face here, the side of the vertical building? Well, if we look at the elements, if we go over 2, so over 20 millimeters, okay, up until it hits the base, and we go parallel to the axis, where it hits the top is a point on the front face of the building, or sorry, is a point on the back face of the building rather. And we can go across and down. Now, a common mistake students will make is they think they're going 60 degrees from 2 meters or 20 millimeters along the XY line, which is wrong. It's on that one. Next one is 1.5, so over 1.5 up, drawing our line, and then the last one is coming from this point on the building, so we can bring that. Right, we're going to draw that out. So up nice and high in the middle of the sheet. Okay, XY line, pick a point for your axis. $60 for your axis. Okay, up 30 millimeters from the XY line. Light horizontal line is a construction line. Heavy 30-degree line here for the base of the building. Okay, now remember we can go straight up there, straight up lightly from the start point of the axis, and then 60 degrees from here. So 60 degrees there until it hits that straight line up. I'll just make that bigger so you can see better. So heavy line there. Okay, now remember, how do we figure out this point here? Over 20 millimeters up 60 degrees until it intersects the top of the cylinder. So over 20 millimeters along the XY line. See, a common mistake from students will be now to draw that way. It's up. That's the element there, and that's the top face of the building. Or sorry, the top of the vertical portion of the building, the rectangular prism. Cross then. Down. There again, down. Now, the remaining two elements, look, up here. There we go. And then this point down. Don't forget your heavy line here. And heavy line there. So that's the elevation completed there. Now that will be worth 19 marks. Construct and draw the semi-cylinder. 8. Construct and draw the vertical rectangle. 8. Straight line elements and complete the end view. So that would be 19 marks. Now, the next thing, right? Project the elevation showing clearly all construction lines. Right, so the key questions students are going to have would be, how do I get the distances between these lines? Right, what I want, line A to C will be a true length because it projects as a point there in end elevation, so it will be parallel to the XY line in plan. So what we need is the true shape of this cylinder. So we need the true shape of the base, right? And that's a circle radius 60, alright, or whatever it is, or when you project down. So we're going to project down perpendicular to that. So we project perpendicular. We take mark in our center line. We take our compass and we draw in the true shape of the base. And the reason we're doing this is because these distances here are true lengths. And how I know they're true lengths is because they project as points in end elevation. That's how I know they're true lengths. And every distance on a true shape is a true length. So that's why I'm doing this here. Alright? And I can bring the points down here. So the distance between these 2 points I just marked in is the equivalent of these 2. The next 2 here I've just marked in are the equivalent of the middle purple line there. And then finally, this one is the equivalent of the third purple line. And then you can go up, right? Now, if you wanted then to figure out how to get them, so I'm going to I'd bring this point over until it hits the 2 outside ones. The second one over until it hits the middle purple generators. There we go. And the third one over until it hits the third purple generators. And you then sketch them in. Okay. And then the ellipse here at the bottom is the same idea. So I bring the top or the bottom of the element over until it hits these 2 elements. The second one over until it hits them. And the third one's over until it hits them, and freehand sketch them in. And the top one is going to be the same. I'd have to bring these out more, extend these up. So bring this one over until it hits these elements in elevation. The second one over until they hit this one, and then the last one, okay, there I just need to bring the last 2 elements up until they intersect there. Right, so I'm going to do that now, but just before I do it, I'll show you, look at it in 3D. So we're using the elements, okay, to get these on the curve. One of the faces projects as an edge view in end elevation. So it's no different from it's the limits method for solving intersection as well as equations. Right, so let's begin. We're going to get the true shape of the bottom. So we're going to project downwards. We're going to take our compass, want to draw in the true shape. So I'm going to label these. That's going to be A/C, okay, 1/2, 3/4, 5/6, and then point B. Now, I want to bring points down. So 5 to 6 is a true length in elevation because it projects as a point in end elevation. Now I'm going to bring the points across. I'll just bring them across then. I will get the outline going. I'll straighten up that visualizer. So it's 180 in length in total. So 3. And then the center line is at 9. So I can draw in the center line. get as much of the outline of the building as I can do at first. So I'll bring this outside line up to the top here. Now, right, that's point B there. Right, we're going to put the elements in. So look, I'm going to take, I can take half the distance between, 5 and 6, just from the center line. Now from the true shape, I'm going to put it on the center line here. And I'm going to swing left and right. So this one, this one is number 6, okay, and this one is number 5. Let's see. Now, next one. Compass here in the middle, out to the circumference there. So, 2 points either side. So that's number 4, okay, and number 3. And the last one here, number 2 and 1. So this is number 2, this is number 1. So what we're getting here now is the elements on the sheet. So we can do straight light lines up. From the numbers. Now, look, where the element intersects the edge of the building, I'm going to bring them over. I'm going to call them the same ones again. So I bring 1 and 2 over. Right, so that's 2. Okay, this is number 1. Right now, 3 and 4. I'm going to bring over until it hits 4, 3, and then 5, okay, and 6. They're the points on it. And what we'll do is we'll freehand sketch them together. So there you have some of the building drawn in there. And then we can freehand sketch these in, which I'll do now. Okay. We can complete the heavy lines on the top of the building. Place. Next we're going to do the ellipse on the bottom of the building, which is very similar. With the ellipse, again look, I'm just going to bring 1 and 2 across. There's point 2, point 1, 3 and 4. 5 and 6. That's point 6, point 5, and then point B across. It's B, and I can freehand sketch them in. Okay, which I'll do now. Freehand sketch them in, and now we have to do the curve at the top of the building, which is very, very similar. We're just going to extend our elements. We're going to extend our elements in end elevation up until they hit the top face of the building. Now, 1 and 2, we're going to bring it across. So there's point 2, point 1. So we can bring 3 and 4 across. So there's point 4, point 3, 5/6 we can bring across. 6 and 5, and then B is at the top, so we can freehand sketch them in as well. And then the last thing then now is we have to find the center of curvature. And just before I go to the center of curvature, it was the marks going for the elevation. Outline a rectangular portion, form our marks, determine the major and minor axis for curve ABC, so that would be bringing over point B. Okay, we'll get you 2 marks. The width of the ellipse will be 1. Determine additional points. Minimum of 6, so 1, 2, 3, 4, 5, 6. There you go, 4 marks. Draw elliptical curve. You don't need me to read it out anymore. You can draw top elliptical curve by a translation otherwise, so you could translate the curve up if you wanted it. So all the points of this is from B to B. Okay, now next thing I'm going to do is locate the two focal points on the center of curvature. So to locate the 2 focal points, we're going to take half the major and swing from the top of the minor. So I'm going to take half the major AC, and I'm going to swing from the top of the minor, which is B. So there's F1, F2, and then to get the center of curvature, okay, I'm going to join B to F. And I'm going to go at 90 degrees to B to F for my center of curvature. So, to get the focal points, take half the major, swing from the top of the minor, there's F1, F2, and then to draw in center of curvature. A lot of the constructions used in tangents are reused in centers of curvature. So join P to F, I'm sorry, F1 to B. You can go then at 90 degrees to line F1 to B. And there's the center curvature for point B. So this for point B. You don't have to do this arc now here. There we go, center curvature for point B. So that's that there, the solution the marking scheme we gave. Then the marks there, they're going to there we go. A picture of it, of a similar thing I did with my 5th years, I think, a couple of years ago on doing orthographic projections. You don't have to do a plan view on that question. Just have to do that. Okay, there's the center of curvature. That's what it looks like in 3D again. There we go. That's it really. Thank you. Cheers. Bye bye.